Okay, good day. This is Honors Algebra 2. I am Mr. McCully, and this is the lesson for section 4.3 on factoring quadratics. So let's get to it. Here are the learning goals. Today we are going to write quadratic functions in standard form, and we're going to solve some quadratic equations by factoring. So first we need to start with some vocab. Oh yeah, everybody loves vocab. Zeros, roots, and factors of polynomial are all related. Zeros and roots are values of x that make the function equal to 0, and factors are linear expressions that divide a polynomial. And so we can make a conclusion: if a and b are zeros, then x minus a and x minus b are going to be factors. And so if we come over here and we look at this diagram just for a moment, if I say a and b are both values where the quadratic crosses the x-axis, then a and b are both zeros or roots. These are synonymous of this quadratic, and that ends up being fairly important in terms of solving problems. All right, and we know that because when you cross the x-axis, the y value is equal to 0. All right. Why is finding zeros of a quadratic or any polynomial for that matter important? Because of the property of the product of zeros. Multiplying by zero is very powerful. It does not matter how many multiplications that you have. If you are multiplying by 0, then the result is 0. And so, put simply, if a times b is equal to 0, then we know for a fact that either a is equal to 0 or b is equal to 0 or both are equal to 0. Because it doesn't matter what the other value is. If you get a product that's equal to 0, then at least one of the elements that you're multiplying by has to be equal to 0. And so we can use that. And in my example down here, I said solve the factored quadratic equation. If we get it down into a product of factors, the power of the property of the product of zeros is that if one of these two factors is equal to 0, the whole thing is equal to 0. So if I can make x minus 3 equal to 0 and x plus 2 equal to 0, then those two x values solve this factored quadratic equation. And so clearly we see, if I plug in x equals to 3, I'll get 0 here. I won't get 0 here. I'll actually get 5. But it's a solution to this equation because 0 times 5 is 0. I will also have, as a second solution, negative 2, because negative 2 plus 2 makes it 0. Negative 2 minus 3 is negative 5, but it doesn't matter because negative 5 times 0 is still 0. Example, given two zeros of a quadratic function, write the quadratic function. Well, here we have minus 2 and 4. And just like in the previous one where we had factors and found zeros, they're giving us zeros and asking us to find the factors. So we can do that. It's just going to be the opposite. So our function is going to be y equal to x plus 2, because negative 2 makes that factor 0, and x minus 4, because positive 4 makes this factor 0. I should finish by multiplying them together. X times x is x squared. X times negative 4 is negative 4x. 2 times x is 2x. And then 2 times negative 4 is negative 8, which will give me x squared minus 2x minus 8. And that is my final function. Factoring by finding a GCF. Solve the following equation by factoring. Now, in general, you should always check to see if there's a greatest common factor. Even if it's just a numerical value, you might be able to make your factoring a little bit easier. In this case, we do not have a constant term. We have the quadratic term x squared, and we have the linear term negative 6x. And there is a common factor between these two terms. That common factor is x. And so when I divide x squared by x, I get x. And when I divide negative 6x by x, I just get negative 6. Now these are both two factors. And based on what we've done here in the previous two problems, we know that 6 will make x minus 6 equal to 0. So 6 is going to be a solution. But x by itself tends to give students who are first doing this a little bit of trouble. What makes x equal to 0? Well, 0 makes x equal to 0. And so when I plug in 0 for x, I get 0 here. I'll get negative 6 in this factor, but 0 times negative 6 is 0. And if you're unsure, you can always go to Desmos and go y equals x squared, right arrow, minus 6x. We can click on each of these two intercepts and we see 0 makes the function 0 and 6 makes the function equal to 0. Solving quadratics with simple factoring techniques. Now, there are three factoring forms here. The one that's most important is this first one. This one here, difference of squares. And you're going to see this quite a bit over the next couple of units, where we're going to have a squared minus b squared factors into a minus b times a plus b. So please make sure you put that one into your long-term memory. These other two are nice to know, but the factoring text that we will discuss later in this lesson will also find these particular factors out of general quadratics in that form. Let's talk about solve the following quadratic by factoring. This is a little bit different than the last one in the fact that we have a quadratic term. We have no linear term, but we do have a constant term. Both x squared and 25 are perfect squares, so this does in fact match this particular form. What we're going to do is we're going to say recall a squared minus b squared is equal to a plus b times a minus b. Alright, so if a squared is equal to x squared, then we can conclude that a is equal to x. If b squared is equal to 25, then b is equal to 5. So this particular factoring expression is going to be x minus 5 times x plus 5 equal to, and since we're asked to solve this particular quadratic, we're going to make each of the factors equal to 0. So 5 makes this factor equal to 0, and negative 5 makes this factor equal to 0. So x is equal to negative 5 and positive 5, and that is our solution. Solving a quadratic by factoring given ax squared plus bx plus c is equal to 0. Now sometimes you can factor, and here is the steps. The first thing you're going to want to do is you're going to want to, this is the a value, this is the c value. Then you're going to make a list of factor pairs of a and c, and you're going to find the factor pair m and p whose sum is b. We're going to rewrite the equation with a sum of mx and px in place of bx. We're going to factor by grouping, and then we're going to rewrite the final product and solve. Now, that may sound confusing at first, but if you follow along, you'll see that this thing makes a lot of sense. So my first example is a simple one, and we wouldn't necessarily need to use this method to do it. Since we're learning, we want to get an idea of how to do it on a simple example. So the first thing we're going to do is we're going to multiply a and c. So what are they? A in this case is equal to 1, and c in this case is equal to 8. So we're going to multiply those together. AC is equal to 8. And then we're going to make a list of factor pairs of AC. So factors of 8, 1 and 8, 2 and 4, And we could possibly do some negatives. We could do like -1 times -8 is 8. -2 times -4 is also 8. But we don't necessarily need all of those. And so what we're going to do is we're going to find a factor pair, which we're calling M and P, whose sum is B. All right? So 1 plus 8 is 9. That is not 6. 2 plus 4 is 6. So this is going to be my M value, and this is going to be my P value. Now, this will probably be the only time I write this out, but that's okay. And so if I go back here, we're going to rewrite the equation with the sum of mx and px in place of bx. So we're going to rewrite this as x squared plus 2x plus 4x plus 8 equals to 0. Now, you'll notice that I've rewritten this equation, but I have not changed the equation. 2x plus 4x is 6x. So the next step says factor by grouping. So what we're going to do is we're going to put groups around this. So we're going to group these two, and we're going to group these two. And now to finish the factoring by grouping, what we're going to do is we're going to do a GCF from each of these two groups. The first one has a GCF of x. And so we'll have x plus 2 here, and then the second one, the second group, has a factor of 4. So I'm going to factor out a 4 here, and I'll have x plus 2. If you have done this correctly, and you can solve this quadratic by factoring, what's left inside the two parentheses, it should be the same value. We should have x plus 2 and x plus 2. Otherwise, we've either made a mistake or you can't solve this by factoring. Now, just like I factored out an x here and a 4 here, I have two new terms. I have a term here and I have a term here. And both of these two terms have a factor of x plus 2. So when I factor out the x plus 2 from this first factor, all that's left is x. And when I factor out x plus 2 from this second factor, all that's left is 4. And now I can solve this by saying x is equal to -2 makes the first factor equal to 0, and -4 makes the second factor equal to 0, and we're finished. Let's try one that has a little bit more difficult of a setup. So let's start finding AC. AC is going to be -3 times 8 is -24. So now I want to find factor pairs of -24 that add up to -10. So let's start with -1 times 24. -1 times 24 is -24, but the sum of -1 and 24 is 23. That doesn't work. The next factor pair, -2 times 12 is -24, but when I add these two, -2 plus 12, I get +10. Now I want to stop here because I can see that I've got the 10 part. All I have to do is switch the signs. And so if I go 2 times -12, I get the -24, and then 2 plus -12 gives me the -10 that I have here. So I'm going to rewrite, so 3x squared plus 2x minus 12x plus 8 equals to 0. Now, some of you might be saying, well, what happens if I switch these? You'll still get the same answer. It'll still work. So don't worry about the order that you put these two middle terms in. It'll still work either way. So we're going to group the first two terms, and we'll have -3x squared plus 2x. And we're going to group these second two terms. Now, if I want to keep that negative in front, I got to go plus because we're making it a group. So it's got to be plus -12x plus 8. Just to be clear. So I look at this first group, and in this first group, the greatest common factor is going to be x. So I'm going to factor out an x. That'll leave me with -3x plus 2. And when I look at this second group, the greatest common factor is going to be 4. So when I factor out 4, I'll get -3x plus 2. And so I see, again, I feel confident in this answer because I have -3x plus 2 and I have -3x plus 2. So when I factor out a -3x plus 2 from the first term, I'm left with just x. And then when I factor out a 3x plus 2 from the second term, I'm left with just 4 equaling to 0. In the second factor, we clearly see that negative 4 is going to make it to equal to 0, but this first factor is not quite as clear. If you're having difficulties, all you have to do is set that factor equal to 0. So negative 3x plus 2 equals to 0, because that's what we're doing. We're saying what x value makes this expression equal to 0? Well, I got negative 3x, and then I'll get negative 2 if I subtract 2 from both sides. And if I divide both sides by 3, I'll get x equals negative 2 over negative 3 will be positive 2/3. So my other factor is 2 over 3. All right, last one. Let's do a application problem. The width of a rectangle is x plus 2 feet, and the length is 3x minus 4 feet. If the total area is 448 feet, then what is the dimensions of the rectangle? So here's what we're going to do. We're going to say that area is equal to length times width. And so in this case, x plus 2 times 3x minus 4 is going to equal 448. So let's multiply this thing out. X times 3x is 3x squared. X times negative 4 is negative 4x. 2 times 3x is 6x. And then negative 2 times 4 is negative 8. And that has to equal 448. All right. So here we're going to get 3x squared plus 2x minus 8 equals 448. So here we have a situation where I have 448 on the right hand side. Now up until this point we have been using this property, the product of zeros, to do our factoring, and it only works when your function is equal to 0. So we have to get this thing to equal to 0. So I've got 3x squared plus 2x, and then when I subtract both sides, I'll have negative 456 equal to 0 there. Now, to get this factoring, I'll have to multiply 3 times 456, and that's going to be fairly difficult. So let's go back to Desmos. And let's enter that equation. Let's go y, and I know it's supposed to be equal to 0, but we'll go y equaling to 3x squared, and then it's right arrow to get out of the exponent, plus 2x, and then it was minus 456. All right, so I'm going to zoom out here, and I see my two zeros. Let's find our first one. Negative 12.667, so negative 12 and 2/3 there. And this one is going to be positive 12. So we have two solutions here for this one. We have x equaling to negative 12 and 2/3, and we have positive 12. Now, this thing is saying, all right, we have a rectangle whose length is x plus 2 feet and its width is 3x minus 4 feet. The problem here is that this particular solution, this negative 12 and 2/3, makes sense in the context of the algebra. It doesn't make sense in the context of the problem. In the context of this problem, only a positive length makes sense. So we have 12 plus 2 will give me 14, and then 3 times 12 minus 4 will give me, let's see here, 3 times 12 is 36, minus 4 is 32. And so if I go 32 times, or 14 times 32, if we go back to our calculator, and we go 14 times 32, we get the 448. So we know that that's correct. So the dimensions are going to be 14 feet by 32 feet. All right, that's all I've got for today. So, the Mandalorian fun fact of the day. In the first episode of The Mandalorian, George Lucas, the creator of Star Wars, appears as a bounty frozen in carbonite in the hold of the Mandalorian's ship, the Razor Crest. That's all I got. Have a good day. Bye.